Okay, so let's talk about how to solve some absolute value equations. Right, so when it comes to absolute value equations, there's all sorts of different kinds. So you're mainly wanting to first focus on what sign you have. Is it equals? Is it greater than? Is it less than? Or do you have two absolute value equations set equal to each other? Because depending on what kind of equation you have, it's going to let you know what you need to do with it. Alright, so if you don't have this particular one, go watch one of the other videos and find the one that has the appropriate sign that you're needing. But essentially, when it comes to absolute value equations, so definition of absolute value says that it's the distance away from zero on the number line. And one thing about distance is that distance is always positive. So hopefully what we do know about absolute value is that absolute value bars always make everything positive. So if it's positive or negative inside here, doesn't matter because it's going to end up being positive. So because of that fact, when it comes to solving for x, we don't truly know, was it a positive value or was it a negative value? We were not sure what it was to start off with because these absolute value bars were going to make it positive in the end. Right, so what we do then to try and figure out which situation we might have had is that we assume for both. Let's assume that we had a positive value in there. Let's assume we had the negative value, and let's solve for both situations. So if you have the kind of example where it's a greater than, this is how it works. When it comes to absolute value equations, to solve them, you always need to split them up into two different equations or two different inequalities. So then when it comes to solving this kind of absolute value equation, so I have an example here. All right, so if you have the greater than example, so I have the little formulas here for you. So you're going to, if you have the greater than example, you're going to solve for these two situations. The first one is going to look like the normal equation, the normal inequality, the way it was given to you. The second one, you always change the symbol and take the opposite of what it said equal to. So regardless what situation you have, you normally always flip the symbol, take the opposite. So for this particular example, right, so I have the absolute value of 2x plus 1 plus 3 is greater than 8. So one thing that you do need to keep in mind before you do anything with absolute value equations, inequalities, is that you want to get the absolute value bars by itself on one side. So if you're given an equation like this one here, where I have this plus 3 hanging out over here, we need to kick that over to the other side because I want my absolute value bars completely by itself. So to start this problem off, what we're going to need to do is we're going to need to subtract 3 on both sides. So when we do that, I'm going to be left with the absolute value of 2x plus 1 is greater than a 5. Now I can take this and split it into my two different equations that I need. So the first one is going to look just like this, minus the absolute value bars. And the second one is going to look almost exactly the same, but we need to flip the symbol and then make this value negative. All right, so these are the two inequalities that we need to solve. So otherwise solving for x. All right, subtract 1 on both sides. 2x is greater than a 4. And then divide by 2. And that's going to leave us with x is greater than a 2. Moving over here, do the same thing. Solve this one as well. So minus 1 on both sides. 1 minus 1 cancels, and we're left with 2x is less than a negative 6 there, right? Negative 5 minus another 1 is a negative 6. And divide out the coefficient, so divide both sides by 2, and x is less than a negative 3 there. So these are our two proposed solutions. Now when it does come to absolute value, here we do need to check our solutions, make sure they do make sense. For the most part, they are going to make sense, but we do need to check just in case. We also, a lot of times, we're going to have to graph these here. So let's check them first. So if we take our equation here, right, let's just rewrite this all over again. Let's plug in the values that we got. So we got that x is greater than 2. Pick a number greater than 2. Let's use 3, right? You don't want to make it too big. And if we plug in a 3 here for x, what would we get? Well, let's see, 2 times 3 is a 6, 6 plus 1 is 7. And if we take 7 plus this 3, we get a 10. All right, so 10 is greater than 8, so that makes sense, right? 10 is bigger than 8. If we do the same thing for our other proposed solution here, so over here we got that x is less than negative 3. So let's pick something less than negative 3. I'm going to go with the negative 4. So 2 times negative 4 is a negative 8. Negative 8 plus 1 is a negative 7. But when we take the absolute value of that, absolute value of negative 7 is 7. And 7 plus 3 is once again a 10. And 10 is greater than 8. So both of my solutions do work out. You do need to go through and run the check though, just to be sure. But let's move on to the graphing part of this. So we need to graph this on a number line. All right, so we have numbers negative 3 and 2. So I'm going to say negative 3 is over here, 2 is over here. So I want everything bigger than 2, so that's a parentheses at 2 because of our symbol. All right, and I want everything bigger than it, so I'm shading to the right. And then I have x is less than negative 3. So because of this symbol, less than, that's also a parentheses at negative 3. And we're shading everything to the left there. So this is our solution graph for this particular example here.